All right, number 16 says a stone is thrown upward from the ground with an initial velocity of 96 feet per second. We want to find its average velocity during the first 2 seconds, given its acceleration is negative 32 feet per second squared. So if acceleration is negative 32, velocity ought to be negative 32t plus some constant. And we should be able to figure out that constant because we know that when t is 0, the velocity is 96. So that should tell us that v equals negative 32t plus 96. And if we want to find the average velocity, this is our velocity function, in the first 2 seconds, it ought to be 1 over 2 minus 0 times the integral from 0 to 2 of negative 32t plus 96 dt. And we'll just integrate that. We got a 1/2 out in front. We got a negative 16t squared, and we got a 96t from 0 to 2. The 0 is going to be 0, so really it's just negative 8 if I take the half to that times 4 plus 48 if I take the half to the 96 times 2. And what is that? Negative 32 plus 96, which must be 64 feet per second. Any questions there on 16? All right. Next one, 21. All right, 21 is a little bit of a complicated one. So 21 says we got the center of a city, and we're assuming that the city is circular. So there's my city, and there's the center of my city. And it says that the density of the population in thousands of people per square mile is given by f of r equals 12 minus 2r, where r is the distance that we are away from the highway. So we're given that the radius of this is 3 of the city. So if we were looking at the distance away from the highway, right, our highway is just this flat highway that goes straight through the middle. Well, our distance away from that highway is just a vertical distance, right? And so theoretically, the density of the city all along, let's say this line right here, should be the same because it's all r units away from the highway. Right? And so we should be able to figure out a formula that represents the total number of people in this tiny little strip right here, right? Some like infinitesimally thin little strip of people r units away. That strip would have a thickness of dr, and it would have a density of 12 minus, what is it, 12 minus 2r, I think is what it was. Is that right? Yeah. So 12 minus 2r. And then we need to figure out what its length is. Well, if this is r and this is 3, this length ought to be the square root of 9 minus r squared. And if I had double that length, that'd be 2 times that. And so this ought to represent the number of people in this tiny little thin strip of land that is r miles away from the highway. Like the density times the length of the strip times the thickness of the strip. And if we just integrate that from 0 to 3, from 0 to 3 up here, that ought to tell us what half of the city's population is. And if we multiply it by 2, that ought to give us the total population of the city. Does that make sense or no? Questions on that one? I don't believe it asked you to evaluate it, right? I think it just gave it to you like that. Yeah. It looks like their answer choice, they pulled the other 2 out and put a 4 out in front, but otherwise the same. Everyone good on 21?
Wait, why did you have to multiply the integral by 2 again?
I multiplied by 2 because this integral from 0, this is 0 to 3 up here only takes care of every flat piece above the highway. But I also have the same exact thing happening below the highway, so I have to double it to take that into account.
Got it, thanks.
Mm-hmm. All right. Next one, 22. Again, a population of a city, this time of a real city, Winnipeg. Okay. And so as we move away from the center of town, so not away from a highway, not a flat highway, but away from the center of town, so going out in circles like a radius r, as we go out away from the center of the town, the density decreases. And we should be able to calculate the total number of people by taking the density in each of these rings, multiply it by the length of the ring. So the length of the ring ought to be 2 pi times the radius. And the density is just our f of x function. So we've got 2 pi r times f of x. And this thing should have a thickness, each of these rings should have a tiny thickness of dr. So what we want to do is integrate this from 0 to 10. And in order to do that, we have to approximate the integral, right? Because we don't actually have a function. So since we know this is a decreasing function, we could, let's see, if we used a left rectangular approximation for a decreasing function, that should tell us that we would be getting an under approximation. So let's see what happens if we do this with a left Riemann approximation. Our first value should be 2 pi times our r value, which is our radius away from the center, which is 0 for the first one, times our 50. And then times the length of that interval, which is from 0 to 2. And the second one should be 2 pi times my r value, or the 2 that we're away now, times our 45 for that y value, times 2 for the length of that interval. And then the next one should be 2 pi times our r value, which is 4, times 40 times the length of that interval, which is 2. And continuing on, next one should be 2 pi times 6 times 30 times 2. And then the last one should be 2 pi times 8 times 15 times 2. And they've all got this 2 pi and this 2 in them. So really we got 4 pi times, let's see, the first one is 0. Second one is 90. Third one is 160, 180, and what's that one? 120. So if we add all those up and multiply by 4 pi, what do we get? Okay, so about 692,000. So we would assume that our approximation is pretty darn close to that 691,200 value that they gave us. Everybody good there with 22? Any questions on 22?
Hold on, could you go over why you took the integral again? I'm a bit confused on that part.
Yeah, so we're taking the integral because each of these rings has a certain number of people in it based on the density times the length of that ring. And so the integral, I mean, the density times the length of the ring times the thickness of the ring tells you how many people are in that ring, and we're summing together how many people are in each of the rings from 0 to 10. So from the very innermost point where we're 0 miles from the city center to where we're 10 miles from the city center. So to sum together all of the x values in here, all of the lengths of these radii, we have to do the integral.
I got it. Thank you.
Yep. And apparently I was slightly misinformed about that. 691,200. But, good. All right, everybody good there with 22 now? Any questions on 22? All right, 25. 25. Oh yeah, we had an issue with this one last period, which we want to know how long it takes to release 9 tons of pollutant if the rate at which it's being released is that function te to the negative 0.3t. And so really all we need to do is integrate from 0 to x of te to the negative 0.3t dt. That'll tell us how much pollutant has been released from 0 to whatever number of weeks we look for at x. And we just need that to equal 9. And so if you're just sitting there on Desmos, you can graph this, and then you can graph y equals 9 and see where they intersect. On your graphing calculator, this takes a really long time to graph, and this is not an integral that you'll be able to solve. So this one, I wouldn't expect them. I mean, in fact, I would say there's no way they would ask you to solve this equation on the AP test with the length of time it takes your calculator to graph that integral for an integral that you can't actually anti-differentiate without rules you have not yet learned. So this is the right setup for 25. And I don't know what I mean, I could look, I guess I can see what does it come out to be. Could do it on Desmos, or I'll just look in the book. The book says that it happens at about 10.2 weeks. So about 10.2. Is that good for everybody with 25? Because quite a few of you asked on that one. You won't have to do something like that on the AP test where the graph just is horrible to graph on your graphing calculator. Any other questions on 25? All right, 26. And 26 is another issue we came across. So I think the book says the answer is D, is that right?
Yeah.
Yeah, so the answer should be E. So if you got E, that's what you were supposed to get. But I'll just real quickly do this. The function was x cubed minus 4x squared plus 3x. And in order to figure out where that crosses the x-axis, we need to factor an x out of it. If I factor an x out, I'm going to be left with x squared minus 4x plus 3, which will be x minus 1 and x minus 3, which means I know that it crosses through at 1 and at 3 and at 0. Which, since I know that this is a positive a value cubic, it's going to go up. It's going to cross through the x-axis at 0, then 1, then 3. So I know it's going to look something like this. You can use your calculator for this one if you wish. You just do an integral from 0 to 1 of our function. And then you subtract the integral from 1 to 3 of our function, because the integral from 1 to 3 is negative. That's a negative integral right there, right? So subtract the negative value, you add them together, and that comes out to be 3.083. And I don't know why they put that as an answer choice. I even looked last time in the back of the book, and they like show their work, and it says this equals 3.083, and then they just say that the answer is D for some reason.
Can you just, can you integrate the absolute value of the function instead?
You definitely could do that. Yeah, you could do the integral from 0 to 3 of the absolute value of f of x. That would also work.
Okay,
Yep.
thank you.
No problem. All right, everybody good there with 26? All right, next one, 31. Yes, 31. We've got this 18-wheeler traveling at a speed, which they're calling v, which is kind of annoying, but that's fine. Our speed equals v, and we know that v is equal to 80 times t plus 1 over t plus 2. We also know that our car gets 4 plus 0.01 v miles per, I'll just write it all the way out, miles per gallon. And we want to know how many gallons does our car use in the first, or this 18-wheeler use in the first 2 hours. So to figure out the number of gallons that it uses, we need to write out a formula that represents gallons per hour and integrate that across 2 hours. Right, so if we have a formula to represent gallons per hour, we should be able to integrate gallons per hour from 0 to 2. Does that conceptually make sense to everybody, what we want to try to do? Hopefully. Okay. So let's turn miles per gallon into gallons per mile. So that would be 1 over 4 plus 0.01 v gallons per mile. And if I had gallons per mile and I multiply my number of gallons per mile by my speed in miles per hour, so gallons per mile times miles per hour, that ought to become gallons per hour. So gallons per hour ought to be 1 over 4 plus 0.01 v times miles per hour, which is 80 times t plus 1 over t plus 2. So we're going to have 80 times t plus 1 over t plus 2 all over 4 plus 0.01 v dt. And then this v will replace with 80 times t plus 1 over t plus 2. So we'll end up with an integral from 0 to 2 of 80 times t plus 1 over t plus 2 all over 4 plus 1/100th of 80 times t plus 1 over t plus 2. And this will all simplify down a little bit if you want to, or you can just integrate that on your calculator. But I believe, if I remember correctly, I believe that integral came out to be 23.1. So 23.1 gallons used in those first 2 hours. Does that make sense to everybody? Any questions on 31? All right. Next one is 20. Okay, another density one here. Our density and number of vehicles per mile along a 20-mile stretch of road. Miles south of some bridge. So here's my bridge, and there's my miles south of the bridge. And it just says that the density is given by f of x, right? Density in cars per mile is f of x. And we know that we are going down here to some value. Here, here's 20 miles down here, but we're going to some value x along 0 to 20. So we just need to integrate from 0 to x our function that represents the density. Because this, at every point, right, which has no thickness any direction to it. So at any point along this line, so I don't have to do like an area or a circumference type thing like I did with the previous ones. It's just the integral of the density there. That's it. That's the answer. Choice A. So like, whereas this one, we had to do 2 pi r times the density because we had a whole ring at which the density was f of x. Or this one where we had a whole line, we needed to find the length of that line times the density. Right here, we just have a point. And so the density at the point integrated should give us the final amount. Does that make sense to everybody for number 20? Any questions on that? All right, we've done 21, we've done 22. Next one is 29. Okay. 29, they give us a little chart here. We want to know when did the 200th visitor go up to the site, and we're given a chart that is in, this is a rate chart. It's visitors per hour, and this is number of hours. And so the chart kind of looks something like this. And we want to know when the 200th visitor got to the site. So we just need to approximate the integral of this, right? If we integrate, we'll call this, did they call it something? They didn't call it something. So we'll just call this r of t. If we integrate r of t from 0 to somewhere, we want to get 200, right? Or we want this integral to be, we want to know when did it become 200. And so the only way to find this integral is just to approximate it by approximating the area underneath the curve. I say we use a midpoint to do that, since we've got some pretty decent, easy to find values. So the midpoint between 0 and 1.5 looks like maybe 5 visitors. So 5 times the length of that interval 1. And then if you look between 1 and 2, it's about 25 maybe. And the length of the interval from 1 to 2 is 1. And if you look between 2 and 3, looks like that's up to about 70 times the length of the interval, which is 1. So now up to 100 to between, what do we just do between 2 and 3? Right, and then between 3 and 4, looks like that adds in another 120 or so. And that would be 220. So this is 3. And then this is the 4th hour. So sometime between hour 3 and hour 4, looks like we went over 200. So choice C. Any questions there on 29? All right. Let's see. We've done 21, we've done 22, we've done 26. We've done 31. Oh, wait, no, not 16, but we did it already. All right, 14. on 14, they give us a current world population of 6 billion. And then the population T years from now is estimated to be 6e to the 0.024 T billion people. We want to know the average population. Well, the function we're given P of T equals the population at any given time after T equals 0. And if we want the average population in the next 25 years, that ought to be 1 over 25 minus 0 times the integral from 0 to 25 of P of T dt. And you'll just plug in your P of T function, which was 6e to the 0.024 T, and integrate this. That's the setup. I don't offhand know what it comes out to be. I can flip and look. Anybody know offhand what that is? Looks like it comes out to be 8.2. So 8.2 billion. Does that make sense to everybody? Any questions there on 14? All right, we've done 21, we've done 22, we've done 25, we've done 31, we've done 16, we've done 21, we've done 22, 23. Have we done 23 yet? No. Okay. Next one. Number 23. So we got a factory that is continuously, how wonderful, continuously dumping pollutants into a river at a rate of root T over 180 tons per day. We want to know the amount dumped after 7 weeks. So we're doing 7 weeks, but our root T over 180 is in tons per day. We're going to have to integrate from 0 to 49, because that'll be 7 weeks. Our root T over 180 dt. And that's really all there is for 23. I don't know what that comes out to be, but I'm sure one of you does. What does that come out to be? Great, 1.27 tons. Any questions there on 23? Okay. I believe next one we need is 28. 28, we've got a bacterial culture that is growing at a rate of 1,000 e to the 0.03 t. And we want to know what the total increase in the bacterial population during the second hour is. So this is our rate of increase, right? And so to find the total amount that it actually increases, we just need to integrate. And we want to know in the second hour, so that would be from t equals 1 to t equals 2, 1,000 e to the 0.03 t dt. And that should come out to be, let's see, looks like it comes out to be about 1,046. Any questions there on 28?
Why isn't it 2 to 3?
The second hour, so t equals 0 to t equals 1 is the first hour. And t equals 1 to t equals 2 would be the second hour. That's what it says right, yeah, during the second hour, yeah.
Okay.
Does that make sense? Yeah.
Yeah.
Cool. Any other questions there on 28? Let's see, 29 we've done. 5, it looks like. All right, number 5. Number 5, we have an acceleration of a particle given to us. And we want to find the total distance that it covers from t equals 0 to t equals 2, so total distance traveled. So first we need to find a velocity function so that we can get a speed function so that we can integrate speed to get a total distance. So our velocity ought to be integral of cosine, which ought to be sine t. And it says when t equals 0, the particle is at rest. So velocity is 0 when t is 0. So velocity is just sine of t. And we want the integral of this velocity function from 0 to 2. We can use the velocity function in this case because if we're integrating from 0 to 2, 0 to 2, any value that you plug into sine from 0 to 2 will always be positive, right? Because that's first quadrant from 0 to pi over 2, and then from pi over 2 to pi, a second quadrant where sine is also positive. So anything between 0 and pi, this will be positive. We could say absolute value if we wanted to, but it's not necessary. So when we integrate sine of t, we should get negative cosine of t. And we'll evaluate that from 0 to 2, which is going to give us negative cosine 2 minus negative cosine 0. Negative, negative, those will cancel out. So this is plus the cosine of 0. So that's a positive 1 minus the cosine of 2. Any questions there on number 5? All right. Let's see here. Number 5, we did. Let's see. Have we done 18? No, we have not done 18. Okay. Next one. All right, number 18, we have a rumor. Oh my goodness, a rumor that's spreading through town at a rate of t squared plus 10t new people per day. T squared plus 10t. Let's not spread rumors. We want to figure out how many people hear the rumor during the second week after it was first heard. So this is number of people per week that hear the rumor. We want to know during the second week how many people hear the rumor. And this is in people per day. And so if we're talking second week, that ought to be an integral from 7 to 14. So day 7 to day 14 of t squared plus 10t dt. That should give you the total amount that hear it during that time period. And your calculator can do that for you if you wish, which is probably best because you probably don't want to cube 14 and then have that many thirds and et cetera, et cetera. So what does that come out to be?
It's like 1,535.
To me, which looks like that's choice B. Any questions on that one? Everybody okay with that one?
So if you were doing the first day, it would start from 0?
Correct. Yep.
Okay.
All right. 22. 2, we have done 25, we did 28, we did 31, we did 31, we still did. I don't see any more on this list. Does anybody have anything else from these that they would like to do today? Or is that it? Is that all the questions? All right.